This conference will now be recorded.
Good morning, one and all. This is A. Rajesh from EC department. My subject is embedded system design for final years, both sections. In the first unit, I want to cover some topics. Objectives, introduction, definition of embedded system, differentiate between embedded system and general purpose computing system, history of embedded system, classification of embedded system, major application areas and purpose of embedded system, characteristics and quality attributes of embedded system. The textbook is Introduction to Embedded System by Shibu KV. The reference book is Embedded System Architecture, Programming and Design by Raj Kamal. So what is the objective of learning this subject is, we will define what is an embedded system. We will look into the history of embedded system and classification of embedded system and applications and purpose of embedded system. So our day-to-day life, we are depending more on embedded system and digital techniques. These embedded technologies are bounding into our daily activities without our knowledge. So as you know, we are using so many embedded devices in all the day-to-day life, such as refrigerator, washing machine, air conditioner, television, DVD players, and music system. So these household appliances are built around an embedded system. Like that, there are n number of embedded system applications in each of the areas. If you select any other automation area, there is also an embedded system. So like that, embedded system is a part of our life. So these embedded system devices we are utilizing without our knowledge, and we are having the power of embedded system, as well as we know the features of the embedded system, and we are utilizing the comfort of embedded system. So what is an embedded system? It is an embedded system. Embedded system is a device which is having both hardware and software, and it is doing a specific task. These embedded system devices are acting as reliable servants. They don't define their identity and they don't command any workload. So embedded system are unique. These embedded systems are unique. They are comprising of both hardware and software. So embedded system is a combination of hardware and software and doing a specific application. If you consider the automation, vehicle automation, our car, it is a best example for intelligent embedded system because its intelligence is varying from headlamp controllers, ignition controllers to that of a airbag control system. So like that, embedded systems are becoming inevitable in all the fields like household appliances, telecommunications, medical equipment, industrial control, consumer products. So as we defined, embedded system is a electronic and electromechanical system. It is performing a specific function. It is a combination of hardware and software. The other name for software is called a firmware. So we are writing some program into an hardware, and like that, using a hardware, we are uh, uh, doing our task, and that is done under control of a software. So embedded system is a microprocessor that controls an automobile engine. So there is an embedded system, there is a microprocessor. That microprocessor is having some program that is going to control an automobile engine. So now you can know embedded system is designed to run on its own without human intervention, and it requires some real-time response. So for that we are using sensors. So these are some of the examples for embedded system, like digital camera, microwave oven, refrigerator, car, electronic toys, satellite system, navigation systems, missile systems, digital watch, traffic light controller, DVD players, washing machine, metro rails, digital camera, medical equipment. So these all like our smartphones, Everywhere embedded system is there. So there is some hardware, there is a software that is called an application software. This application software is going to give certain commands to the hardware. So based on that, the hardware will operate and it will do the specific task. So embedded system can be thought of as a computer hardware system having software embedded in it. It can be an independent system or it can be a part of a big system. So an embedded system can be an independent one and it can be a single device or it can be a part of a big system. Now embedded system can consist of a microcontroller or microprocessor designed to perform a specific task. So as I told, these embedded systems are designed for a specific task. An embedded system designed for controlling an fire alarm cannot be used for washing the clothes. So a fire alarm can only sense only smoke. So what an embedded system is consisting of? An embedded system is consisting of three components: one hardware, one application software, and one OS. That OS, in terms of embedded terminology, it is called real-time OS because most of the applications of embedded system are related to real-time, which are time-critical systems like your missile launching system, aircraft. So there you require time-critical systems. So the response must be deterministic. So you have a hardware that is a processor, that is a core of the system, application software, a program which is going to control the hardware. You require some sensors for input, you require from actuators to give the output, and this all is controlled by one real-time operating system. And this is going to schedule, this RTOS is going to schedule which application must be done in the application software, and it is defining the way the system is going to work. And during the execution of application program, based upon the input, real-time input, it will do the scheduling and initialization of activities. So a small scale embedded system may not consist of this real-time operating system. So all the embedded system devices may not have this operating system. Some embedded systems, like our small scale embedded systems, will consist of only hardware and only application software. But some large embedded systems will consist of real-time OS. So you can define now embedded system as a microcontroller based, software driven, reliable, real-time control system. So we can define our embedded system as a microcontroller based, software driven, reliable, real-time control system. So from this we can design the structure of an embedded system as a sensor which will measure the input, the input which can be a physical quantity that is converted to an digital signal. This sensor will convert your input quantity. It can be a temperature, it can be a pressure, anything depending upon the embedded system application. It will convert your input physical quantity into an electrical signal. So that is called a sensor. Okay, then the sensor output electrical signal must be converted to a digital signal by an A to D converter. That digital signal is sent to a processor for processing and it is stored in the memory. You can use a processor, you can use an ASIC. ASIC is the application specific IC. So what is the application specific IC is? Processor means it can be normal 8085 processor or 8086 processor, or it can be any high any big processor. But ASIC means it is specially designed for that. Like if you have any product from Samsung company will create their own IC hardware processor for that specific application. So it can, the core of the embedded system is a processor or ASIC. Then there is a D2A converter. D2A converter means whatever the processed data is there, that is again converted to an analog signal. That analog signal input is given to an actuator. So what actuator does is it will compare the output given by the converter to the required one and generates the output. Like our embedded system called AC, air conditioner. What is the purpose of AC? Air conditioner will control the room temperature. So air conditioner will have a sensor. It will measure the room temperature. Based upon that, an electrical signal is generated that is sent to the hardware part. That hardware part is going to sense one more temperature from the user who is going to set on its remote the temperature required. For example, the room temperature sensed maybe is some around 38 degrees, but you want to make the cooling to 25. So what you do is in the remote you sense it as a 25. So once you keep it is 25 as your 25 degrees Celsius, and room temperature sensed is 38 degrees Celsius, the difference, based on the difference, this processor will generate the signals that are sent to an actuator. So this actuator will control the motor, so that motor will run and cooling will come from the AC outlets, so that the room temperature reaches to from 38 to 25. Once both temperatures matches, further motor will be shut down. So like that, your air conditioner system is going to sense present temperature and temperature set by you, and it is going to make the room cooling, or it will maintain the same cooling. So from hardware point of view, if you see, a washing machine is an embedded system where hardware, it consists of buttons, displays, and electronic circuitry. If software, if you see, it will be having a chip which is holding the software, and it will control all the operations. And the mechanical components is the internal to the washing machine. It consists of the place where the clothes are washed, and it is controlling the input, output, and also chases. So this is the air conditioner example. The hardware part is a remote display, infrared sensors, and electronic circuitry. Software part is a chip which is holding the software. The software is going to drive or monitor the various operations in order to be given to the sensors to or to the coolant. Okay, so what is the mechanical component? Internals of the air conditioner, the motor, the chassis, and outlet. Okay, so these are the two best examples of embedded system: washing machine and air conditioner, where we are going to control one parameter, do the specific task based upon the program given in a application software, and that program is going to control the hardware, the processor. It can be any processor or any ASIC, anything. So in a similar way, there is an elevator. Elevator is a lift where multiple people want to move from one floor to another floor. So it's going to check which floor this elevator is in which floor, and based upon the input and based upon the program given, it will either go to one of the floors as designed in the program. So that is also, elevator is also one of the examples for embedded system. So coming to embedded system, as we have understood, embedded system is a combination of hardware and software, and it is doing a specific task. So we are going to compare this with general computing system. What is a general computing system? Embedded system is a hardware and software combination. Similarly, general computer system is also a combination, but the difference is embedded system is having a special purpose hardware, and the OS is also an embedded OS doing a specific set of applications. Whereas general computing system is an desktop PC. It is having a hardware, and the purpose OS is also a general purpose. You can use any Windows for that. For general purpose computing system, you can use a Windows or Linux. But when you go to embedded system, you have to use RTOS, where it requires real-time OS. So embedded system requires a real-time OS. General computing system requires normal OS. Sometimes embedded system may or may not contain OS, like electronic toy. An electronic toy is having some program. That program is going to control the hardware, so it may not require OS. But general computing system such as some desktop PC, personal computer, contains a OS, and the program software of embedded system is pre-programmed by the manufacturer. User cannot alter it. So you cannot alter the program given in an embedded system, whereas application softwares on a desktop PC are alterable. Okay, so you can install Unix, Windows as OS. Then you can also install C language or some other MATLAB language. Okay, and what are the key deciding factors are it is only specific application. Here we see the performance in desktop PC. Here we will see specific task is met or not. And in embedded system, power management techniques we are going to use. In general computing system, we will not concentrate on the power. And response time is we require time critical depending on the application. Electronic toy, it may not require time critical. Okay, if it is a electronic toy, if it is operating after 5 minutes, it is okay. But if it is a missile, we require a time critical system. Missile must be hit at the exact time. And for computing, general computing system, your response time may not be time critical. And embedded system behavior must be deterministic. Deterministic means it must be exactly what you expect it. Computer, it need not be deterministic. You do some programming, okay, based upon the delay of your computer, you get a result after some time. We can accept in general computing system. So like that, embedded system is specific, hardware is specific, software is specific, OS is specific. So that's why it is RTOS, and power management technique is involved. It is a time critical depending on the application. Coming to history of embedded system, the present embedded system available in all the areas has started from, it's the first embedded systems called Apollo guidance system and Minute One missile system. These two systems are having different architectures. They developed these systems by MIT labs. The memory requirements, the clock frequency was less. At that time, they started this Apollo guidance system with 11 instructions, 16-bit word logic, only 5,000 ICs. But once in 1971, our 4004 processor came into existence with the ICs, integrated circuits. Thereon, so many embedded devices came into existence. Classifications of embedded system. So you can classify the embedded systems based on generation, based on the complexity and performance requirements, based on deterministic behavior, based on triggering. So classification based on the generation. So these embedded systems started developing and the applications done are going on increasing. They started with some electronic toy, and now they're keeping these embedded systems in all missiles, aircraft systems, automation cars, all industries, but the level of application done is different. So an electronic type purpose is only to play the program, play the music. But whereas the aircraft missile system, we have to hit the target. So it is more time critical. This is not time critical. So based on that, they have classified based on the generation. What is the generation? Generation is decided based upon the hardware used. So based on the generation, we have first generation embedded system. These first generation embedded systems are built around 8-bit microprocessor and microcontroller, simple hardware and firmware used. The best example is digital telephone keypads. So these digital telephone keypads are coming under first generation. Second generation, they are built up around 16-bit microprocessor and 8-bit microcontroller. So the microprocessor is a 16-bit microprocessor, microcontroller is a 8-bit microcontroller. They are more complex, more powerful, and the example is SCADA systems. The SCADA systems are coming under this classification. Classification based on the generation. Third one is third generation systems, 3G systems. Your embedded system, if it is built around 32-bit microprocessor and 16-bit microcontroller and doing applications like digital signal processing, ASICs, then it comes under third generation. Example is robotics, media, etc. So this multimedia applications, robotics, they come under third generation. And the next one is the fourth generation. These are built around 64-bit microprocessor and 32-bit microcontroller. So an embedded system built with 64-bit microprocessor and 32-bit microcontroller, and we are using, other than microprocessor, we are using system on chip and multi-processors. So dual core, quad core. So we have increased the level of applications. So we are in all missile systems, we are going to use this such type of hardware. It is highly complex and very powerful. And example is smartphones. Our smartphones are built around dual core, quad core, and the processor is 64-bit Mac processor. This is 4th generation. So based upon the generations, we are having 4 classifications. And the next classification is based upon the computing and performance. So first classification is small scale embedded system. What is a small scale embedded system? Small scale embedded systems are also having hardware and software, may not have OS, may or may not have OS. They look very simple. They are not time critical. So your response may not require to be critical. It is low performance and low cost. Example is electronic toys. So electronics toys are coming into classification of small scale embedded system. Medium scale embedded system. They are slightly complex in hardware and software. They are having a medium performance. They are having low cost and contain OS for functioning. So in all industrial machines, we are seeing all industrial machines, we are seeing this medium scale embedded systems. Coming to large or complex scale embedded systems, it is having a high complex hardware and software. It is demanding high performance 32 or 64-bit RISC processors. It contains multi-core processors, co-processors, and contains RTOS for task scheduling and assigning the priority to the task. See, sometimes some other task is coming into picture, and our existing task must be temporarily stopped, and we have to assign another. Our processor must be given duty to another task. So in such a application is called large or complex scale embedded system. Small scale, medium scale, large scale. So under large scale, our example is mission critical applications. Mission critical means our best example is missile launching, aircraft, vehicle. See, whenever there is an accident occurring, so it has to control the speed. It has to, other than controlling, the first operation it has to do is, if you consider any vehicle, car, it is having so many embedded intelligence involved. It will be having sensors. It is going to tell any vehicle if it is approaching, what is the speed. It will show all the display. But other than that, first what it does, if any accident is occurring, it is going to open the airbags. Okay, so airbag is the first application to be done. Priority. So there comes the priority. Airbag control system is intelligence of a car, which is done first among all the other applications. Similarly, anti-lock brake systems. Okay. So one more classification based on the deterministic behavior. See, our main purpose of embedded system is we want our device to be a deterministic. Deterministic means it is same as required. Okay. We will not accept any deviation. So all real-time systems will come under this classification. The task is, it can be deterministic, non-deterministic, but embedded systems are classified into based on the deterministic. Those devices which come under deterministic, they are one category. Those will come under non-deterministic, they are another category. So these deterministic systems are called real-time systems because real-time response is considered. That real time is also again hard and soft. So real time means real time data is calculated, then your embedded system will give the response. Among that, it is hard and soft. Hard means it should be exactly, small deviation also you cannot uh, accept. So fourth classification is embedded systems based on triggering. So they are called reactive based on the triggering. These reactive systems are event trigger and time triggered. So some even embedded systems are related to event, some embedded system related to time. So based on that, these two systems are called reactive, and this classification is called event triggered and time triggered. Coming to the major application areas, the televisions, the stereo, remote control, phone, mobile phone, refrigerator, microwave, washing machine, electric toothbrush, microwave ovens, watches, alarm clock, musical instruments, toys, medical equipment. These all areas we are using our embedded systems. Applications of embedded systems. See, as we have classified our embedded systems based upon the generation, based upon your complexity, based upon deterministic, based upon triggering. Similarly, one more classification is there based upon the embedded system utilization. Embedded system, if it is utilized in industry, which industry? Okay, if it is used in a specific purpose. So all embedded systems related to home appliances will come under consumer or household appliances. Okay, so household appliances. So those embedded systems which are related to medical, they come under healthcare. So one more classification they have given. These products are n number of, and they are countless. So because day by day, many number of embedded systems applications are coming into picture, and they are categorized into certain categories. First one is consumer electronics. Camcorders and cameras are coming under consumer electronics. Household appliances such as washing machine, refrigerator, the televisions, they under household appliances. Automotive industry, it is anti-lock braking system. See, whenever a vehicle is applying brakes, so there must be an anti-lock braking system and engine control. So that is coming under embedded system. Home automation and security system like fire alarms, they are come under home automation and security system. Telecom, cellular phones, telephone switches. So cellular phones and telephone switches come under telecom. Printer scanners will come under computer peripherals. Any network routers, switches, they come under computer networking systems. So the subheading is one classification called computer networking system is there. So this network routers and switches will come under an embedded system belonging to category of computer networking system. Like EEG and ECG machines will come under healthcare systems. Automatic teller machines will come under banking and retail. Barcode and smart code readers will come under card readers. So there is a classification of embedded systems called banking and retail, where you are going to use ATM machines as example. Then card readers means barcode and smart card. So ATM cards or any card used for swiping and utilizing the transactions, that all come under card readers. Say one more is the purpose of embedded system. So this purpose of embedded system, what it tells is your embedded system is doing a lot of purposes. So these purposes are also classified into some categories. So you want an air conditioner to control the room temperature. So if you want to control the room temperature, first what you do, you are going to sense the room temperature. So you require a sensor. So in a similar way, any number of applications you require an input. That input is coming under, that can be done by a sensor, or it can be an image, or it can be a textual, anything. So your embedded system can get data in any way. So that is one category. That category is converted to another category, required category, because electrical signals are the required for electrical signals are required, that to discharge signals are required for your processor, and input is any physical quantity. So from physical quantity, electrical signal is generated. That electrical signal quantity must be discharged. So for discharging, you require one more category of, that is one more purpose of embedded system, that is met by one more device. Similarly, processing is done by and one more hardware. Okay, so finally the results must be given to the actuators. So based on that, all the embedded systems are doing the same purpose: sensing, converting into the required format, doing some processing by a processor, then again converting into the required format, then it is given to the output devices. So this logic is converted into serving the purpose of embedded systems by data collection, storage, representation, data communication, data signal processing, monitoring, control, application specific user interface. So there is one classification called control. There is classification called monitoring. So this is one purpose done by embedded system, served by embedded system. That purpose is shown as one classification. Data collection, storage, and representation. Embedded system is designed for purpose of acquisition of data from the external world, and this data, whatever we acquire, that must be stored, it must be analyzed, and then it must be transmitted. And the data can be an analog form or digital form. So whatever the embedded system with analog data capturing techniques you are doing, it must be digitized by an analog to digital converter. If digital data is directly captured, then you must have a digital system. So data collection, storing, and again representing in the memory in some format. So the example is a digital camera. Digital camera is going to capture it, then it is going to represent in terms of a graphic LCD unit through a. So whatever the data you have captured, that is stored, and it is represented on a graphic LCD unit. Data communication, because embedded system can be a single system or it can be a part of big system. Your digital camera placed at one place, maybe it can transfer the signals. It is a requirement. It must transfer the signals to a distance place by either wireless mode or wired mode. So you require a communication. This communication is done by wireless modules or wired modules depending on the requirement. If it is a security system of a house, it can be a wired one. But if it is any military applications or any company data, we require wireless. So the embedded data must be transferred using satellite systems by either wired or wireless, and data can be in either form, analog or digital. If you consider the wireless modules, Bluetooth and Wi-Fi, we can use it. Zigbee, Bluetooth, Wi-Fi. Okay, these are the wireless protocols for transferring the data. Wired data means there is a USB protocol, TCP/IP protocol. We are having hubs, routers, switches for transferring the data. Next purpose of embedded system is to serve the requirement of signal processing. So whatever the data is sensed, that is transmitted by a data communication purpose. Then the next purpose is data signal processing. The embedded system is going to do the signal processing like speech coding, audio video recording, transmitting. So these are the data signal processing. The example is digital hearing aid. Digital hearing aid is used for people who could not hear. So digital hearing aid improves the hearing of the hearing impaired person. Once it is placed, the data, it is processed within him, it is modulated. So whatever the data he is listening through a digital hearing aid, it is processed in the digital signal processing unit, and it is maximized. It is boosted up. The electrical signal is boosted up, and it is sent to hears. Like that, a person who is unable to hear, with the help of digital hearing aid, he solves the problem of hearing. And now, and with the help of that, he can improve the hearing capacity. Next purpose is monitoring. See, these embedded systems are also classified into one domain with the monitoring functions. See, all medical applications require electrocardiogram machine, which is going to read the heartbeat of a patient, and we cannot control it. We can only monitor it. So for monitoring, you require one device such as CRO, digital multimeters, and logic analyzers. They just show the response on certain devices. The next purpose of an embedded system is control. So we require a control functionality. So as the sensors are sensing the input, and it is one variable, and that is uh, converted into a another variable, and it is sent to the output. So the example is air conditioning system. It is used to control the temperature of a specific. So this is one purpose served by the embedded system control application. Like as I told, air condition system is going to control the room temperature into a specific limit. Application specific user interface. All embedded systems are having some hardware part that is coming under application specific user interface. Other than sensor actuators and this internal processing part, we also require some hardware part which is going to help in getting the data, capturing everything, processing such as buttons, switches, keypads, lights, bells, displays. So these are the purposes done by buttons, switches, keypads, lights, bells, display. So best example is mobile phone. It is an application specific interface. So the mobile phone, the user is provided with a keypad, system speaker, and vibration alert. So if the person using mobile, you want to dial, he requires a keypad. If you want to speak, he requires a speaker, and he requires a vibration alert. If any phone is any call is coming or any alarm we want to keep, we can keep it in order to get the notifications. Characteristics of embedded system. See, characteristics and quality attributes. So this topic, what it tells is these embedded systems perform a specialized function, and some of the applications they do repeatedly. Like a pager will function as a pager. Okay, so it is a single function. Its characteristic is single function. A pager will always function as a pager. Tightly constraint is one more characteristic. All computing systems constraints on design metrics. So based on the design metric, your embedded system is characterized like depending on the cost, size, performance, and power requirements. It is one of the characteristics. This embedded system, it can have a single chip, it can process in real time, and it can consume less power. So these are the constraints we are putting on the embedded system. They can be reactive and real time. So reactive means they reply like a car cruiser controller will monitor and react to the speed and brake sensors. It will compute acceleration or deceleration within a limited time, and a delayed computation will also lead to the failure to control the car. So this is coming under one characteristics that your embedded system must be reactive and it must be real time. And your one more characteristic is processor based. So some processors are having its instruction set complex, some are having less complex, some are using RISC architecture, some are using CISC architecture. So this hardware is going to decide its performance and security, and based upon the memory, it is one of the characteristics. See, this is not a classification, this is only the characteristics. So based upon the processor used, how good a embedded system is. Okay, so the processor used in electronic toy is simple, the processor used in a missile system is a complex one. So similarly, memory also, less memory we are using, more memory we are using, we require any secondary memory. So that is a characteristic. So based upon the size, if embedded system is very big or embedded system is a portable, so this is only characteristics. Characteristic is telling that it is a single function or tightly constrained, or it is a processor based, or it is a reactive or real time, or how much memory it requires, and how it can be connected. Because some embedded systems need wired communication, some embedded systems require wireless communication, and what is the hardware and software utilized. So like that, this embedded system is coming under coming having these characteristics. Coming to advantages of embedded system, advantages means after embedded systems came, we are able to do our many works in a simple manner. Like we are having dishwashers, washing machines, air conditioners, televisions. So, and all are customizable. What is customizable? Customizable means they are easily customizable. Means an embedded system presently used with few modifications, it becomes one more advantage over the previous system. That is customizable, and they are consuming low power. They are having low cost. It is having enhanced performance, but there are two disadvantages. We need a development effort. See, washing machine, what it is doing now, it is taking some input. It is washing the clothes. It is doing rinsing, drying it. Then this all is done in certain time. So it requires input water. So everything it is programmed by some programmer in application software, and the processor is at a time it is taking the water, it is doing in the dish, in a dish within that stainless tub, it is going to wash the clothes. So how that is done, this is all the development effort. So we require a development effort for getting an embedded system for a specific purpose, and larger time to market. So the larger time to market, because all applications are specific and requirement based. So based on that, based on this, we require large time to market and high development effort for getting this embedded system. So with this, I will conclude my session. Thank you.